In this video we have the integral of tangent to the fourth of x over 2 multiplied by secant to the fourth of x over 2. And normally we expect some type of U-substitution here. Play around with the derivatives. We know that the derivative of tangent is secant squared. We know the derivative of secant is secant tangent. And what we do is going to depend on the powers here. See, if I break up the secant to the fourth into secant squared and secant squared, I'd have a secant squared, and that could lead me to letting u equal to tangent. So let's do this. Say the integral here, and it looks like it will work because I can break up, got this identity here, fundamental identity, 1 plus tangent squared theta is equal to secant squared at the same angle theta. So if I let u equal to tangent of x over 2, then my du would be, derivative of tangent would be secant squared of x over 2, and with the change rule, I would have to multiply by the derivative of x over 2, which is 1/2. I'll put this over 2, and then this will be a dx. Multiplying by 2 here, this will be 2 du. This would be secant squared of x over 2 dx. So tangent to the fourth of x over 2 can be replaced by u to the fourth. So u is tangent, so putting u here, this will be u to the fourth. So I'm trying to transform this integral into one involving the variable u. So I got that much right there. So that's for this one. And then secant to the fourth, I'm going to break that up into secant squared and secant squared. So this one, secant squared times secant squared. And of course the angle is x over 2. But just to let you know what I'm doing here. So then this secant squared of x over 2 can be replaced by, over here, 1 plus tangent squared of the angle. So this will be 1 plus tangent squared, and our angle here is x over 2, so that's the u. So this will be u squared right here. Secant to the fourth, broke it down to secant squared and secant squared, and with this secant squared here, replace it by 1 plus tangent squared, using this identity over here of the angle, which is x over 2, but tangent is u, so I got this. And then this part over here, that is using this secant here. So now this is secant squared here. That's what's left here after factoring this out. So secant squared here of x over 2 dx, that's your 2 du. So I'm just going to put a du right here. And then the 2 can come out in front. There you have it. So then I got 2. The integral of, let's just multiply 2 there. This will be u times u to the fourth times 1 is u to the fourth. Plus u to the fourth times u to the second is u to the sixth. And I got the du. Now this is just basic integration here. Integrating with respect to u. So this will equal to 2. And integrate then. Add 1 to the 4, I get u to the fifth. And then divide by 5. Same thing with the next one. Add a 1 to the 6, I get u to the 7th. And then divide. And then it's plus the constant of integration. And then we just go back to the original variable then. So when you have a u, you put tangent of x over 2. So this will be tangent, is just to the fifth, of x over 2. And then it's times the 2 here, so this will be 2/5 in front. I could put it like this, 2 there, and then the 5 over here. So I'm multiplying the tangent to the fifth of x over 2 by 2/5. Then it's a plus, and then it's 2 times the next one. So this will be 2, and then u, again, is tangent. In this case, it's taken to the 7th power. That'll be 7 there, x over 2. So put the 2 here, the 7 over here, and it's plus the constant of integration. So the final answer then is 2 tangent to the 5th of x over 2 over 5, 2 times tangent to the 7th of x over 2 over 7, plus the constant of integration. Thanks for watching. We'll see you next time.